Does securing microservices for zero trust, leveraging mutual TLS, need to be a complex and convoluted process? We certainly hope not, because the more steps that need to be taken to secure an application, the less likely it is that application teams will get it right. So we certainly want to ensure that when we talk about zero trust, we are talking to the four key pillars for zero trust, namely the establishment of a strong workload identity with the attestation of the source of that identity. Secondly, that there is authentication as well as authorization of the individual transactions or requests, together with an audit log of what transaction occurred at what time between what pairs of identities. And to illustrate the scenario, we are going to use a sample bookstore application demo, which consists of a book buyer microservice talking to a bookstore, which in turn talks to a book warehouse, which uses a MySQL database. And to illustrate the security scenario, we are going to also launch a book thief application, which could illustrate a compromised microservice or perhaps an attacker that has gained access to your infrastructure in some other manner. And given that the bookstore microservice has been written in Golang, we have already updated the bookstore microservice to leverage QuicSec middleware, which is in this case is a one-line change. So let's go take a look at what we have in the cluster we have deployed. We'll talk to the certificate management when we wrap up the demo. We also will talk to the add-ons installed by QuicSec for observability, such as logs, metrics, dashboards, and other audit logging. For now, let's go ahead and deploy the bookstore microservice application. And as the application deploys the service accounts and the various deployments for the different bookstore microservices, you will notice that these start up fairly quickly with essentially just one container running in the pod. In other words, there are no sidecars or proxies or other intermediate points from the application. So right now, everything is running natively within the application pod itself. Given that these pods have now started up, let's go access the user interface for both the book buyer as well as the book thief applications. And we do that with just a simple port forward to their UIs. So let's go take a look at the user interfaces. Let's start by looking at the book buyer user interface. And as you can see, it shows that it is able to successfully access the bookstore microservice, which has now been updated to version 3. And in effect, the count of books incrementing indicates that it is successfully able to access the microservice. Similarly, if we go access the UI for the book thief microservice, we notice that it is also able to access the bookstore microservice, and its count of books is also incrementing. And this is what we want to prevent using mutual TLS. Right now, by virtue of TLS being mandatory in HTTP3, what is occurring is all of these transactions are occurring with one-way TLS. But now we want to enable mutual TLS such that bookstore can authenticate the peer that is talking to it. So to perform that, what we're going to do is we're going to go to the manifest for the bookstore microservice, and we are going to set one environment variable called TLS enable, and we're going to set that to 1. And what that says is that from that point on, QuicSec is going to now look at the authorization rules defined in QuicSec config. These could be very simple rules defined by the application owner, or these can have plugins to external web application firewalls or policy engines that provide more sophisticated security policies and governance. And if we look at the policy rules currently defined, we just have a very simple authorization rule indicating that the book buyer should be allowed to talk to the bookstore microservice, and that the book buyer service account and the book buyer namespace will be allowed to talk to essentially bookstore. So let's go ahead and save this manifest, and let's make sure I saved it, and let's go ahead and apply it. In theory, we just need to set the environment variable, but assuming we're using a sudo GitOps process here. Let's go ahead and apply the new manifest, which means that the bookstore microservice is essentially restarted with the new configuration. And now that it is running, let's go revisit the UI for the two microservices. We notice that the book thief UI indicates that the count of books has stopped. In other words, book thief is no longer able to successfully access the bookstore microservice. This is exactly what we want, because we have created an authorization policy saying which does not include book thief as an authorized identity. In other words, book thief no longer is able to access the bookstore microservice. If you go access the book buyer microservice, we notice that the book buyer continues to increment. In other words, book buyer continues to work. So this is exactly what we want, and book buyer is being allowed to complete its transactions with bookstore, but book thief has essentially stalled. To verify that this is indeed what is happening, let's go look at the logs for the bookstore microservice, which are being dynamically generated by QuicSec on behalf of the application. And when we look at the logs, we notice that in the last few seconds, the logs indicate that the bookstore microservice is seeing requests from book thief, which are not being authorized. In other words, the book thief requests are being denied. To verify that on the dashboard, we actually go look at the dashboard of requests. We see a small number of requests coming in from book buyer, but book thief has seen 0 requests. That's also visible in the request dashboard here, which shows that the last few seconds, book thief has stopped being able to send requests, but bookstore continues to send requests as normal. More interestingly, if you go look at the dashboard, we see that the book thief is again dropped to 0 like before. Bookstore, which is this little green line, continues to flow along normally with a small rate of requests, so it is being allowed. And more interestingly, if you look at the connection failures, we notice that there is a auth failure where the lack of a valid SPIFFE ID from the inbound connection is being denied, and that leads to a crypto error in this case. So in effect, what we have demonstrated is that by using a simple one-line environment variable change to the application manifest, we are able to enable mutual TLS for the application between different microservices. And what this leverages behind the covers is different plugins for enabling this, including cert-manager, and specifically the cert-manager-csi-driver-spiffe, which automatically attests to every workload in the cluster, creates short-lived certificates with a lifetime of 1 hour, and rotates these certificates automatically. But all of that certificate management workflows are made transparent to the application. The application developer does not have to worry about that. That is all taken care of by QuicSec. Likewise, we also have the metrics and logs automatically generated on behalf of the application. And even though some basic dashboards are provided by QuicSec, in the real world, these can be easily incorporated within a larger enterprise observability platform. So what we have demonstrated is how we have assured that the different workloads can enable mutual TLS amongst each other with a simple one-step process. A simple demo of how it is possible to easily enable mutual TLS leveraging QuicSec. Come join us in the QuicSec community at quicsec.io or on GitHub and collaborate with the rest of the community here that is focused on assuring a simpler, cleaner, and yet more secure world, leveraging the power of HTTP3. Thank you.